Hello everyone, welcome to the video on Mathematics 8. Today we're going to talk about modeling using ratios. Before we start the class, there are some things that you need to know how to do, such as writing the ratio form into a fraction form, and also the vice versa, writing a fraction form into a ratio form. After this video, you should be able to set up and solve equations called the proportions to find the missing numbers in the ratio problems. Let's try the first example question together. Solve for x. 25 to 12 is equal to x to 120. So the first thing that I like to do when I look at the ratio problem or a proportion is I don't like ratios to deal with. Well, what I do know is that if I switch it to a fraction form, like this, I know how to deal with this type of equation. We've already talked about our one-step equations, two-step equations in the previous videos. So how do I solve this equation? Well, there's multiple ways we can solve this, but the method I'll use in this case is I'm going to isolate the variable x on the right-hand side. And I think I can achieve that by multiplying by 120 on both sides. I'm multiplying by 120 because it's x over 120, x divided by 120, and we can undo divided by 120 by multiplying by 120 on both sides. So that will cancel out the 120 on the right-hand side. So I have x on the right-hand side. And on the left-hand side, 120 times 25 over 12, 120 and 12 are reduced and leaves a 10 in the 120. So that's 10 times 25, so that's 250. So we found that x is equal to 250 in this question. This type of equation where we show that two ratios are equal to each other, that two ratios are equivalent to each other, we call that a proportion. Proportion is the type of equation where two ratios are the same. Let's identify this, let's annotate this question. So this is, first thing that we did was we switched to the fraction form. And then I isolate the variable. So multiply both sides. By 120. And we have solved the question. So this is, again, to write it down, this is a proportion. Proportion is simply an equation of ratios. Let's try the second question. If the ratio of red yarns to blue yarns is 3 to 5, and there are 48 yarns in a bag, how many red yarns are there? So, when this is a word problem, well, this is a modeling using ratios, so there are the word problems to solve. And also, this question is quite complicated. Let's break it down into pieces. The first thing that I'll do is I'm going to write down the ratio that we know of. Let's call it the red to blue is equal to 3 to 5. However, the information that I know about this question is that there are 48 yarns in total in a bag. We don't know exactly how many red yarns or how many blue yarns there are. In other words, this ratio itself is not that useful. Well, can we switch it? Well, the information that is given is a part-to-part ratio. Do you think we can switch this part-to-part ratio into a part-to-whole ratio? It'll be nice if we have some kind of ratio like red to all, wouldn't it? Well, in fact, because we know that the ratio of red to blue is 3 to 5, well, in total, there must be 3 plus 5, that's 8. So I think we can safely say that the red to all ratio is 3 to 8. Once again, what I did is I added 3 and 5 together, so we know that in this ratio, the red to all is 3 to 8. Now, I think we can use the information that we have 48 yarns in this bag. At this point, let's declare the variable. Let x be the number of red yarns. I declared x as a number of red yarns because the question is asking for the number of red yarns in this problem. And now we can replace the red and all in this proportion. Red is replaced with x, all is replaced with 48, and the right-hand side stays the same. So now we have a proportion, x to 48 equals 3 to 8. Once again, let's switch it into a fraction form. For this question, let's use the other method called the cross multiplication. Cross multiplication is useful when we're solving a fraction equals fraction, which is just the type of equations that we're solving right now. The cross multiplication is called the cross multiplication because we multiply the opposite sides of the equations. So the x and 8 are multiplied together, and 48 and 3 are multiplied together. 8 times x is 8x equals to the 48 times 3, I think it's 144. And then finally, we solve this equation by dividing by 8 on both sides. So x is equal to 16. I think to answer the problem, we need to answer in words. So I think we can say there are 16 red yarns. Sorry, my bad. 18. My bad. 18. 18 red yarns. We can quickly check using the original ratio. 18 red yarns. If there are 18 red yarns, it must mean that we have 30 blue yarns, which still keeps the equivalence in the ratio. Let's annotate the process here. So first thing we wrote is that after you write the ratio in the ratio form, we convert part to part into part to whole. So in this case, what I did was I did the 3 plus 5. It's equal to 8. So I used the 8 as the ratio for the all yarns. And then we declared the variables, set up the equation. So in this case, the setup, the equation, it means that we're setting up the proportion. Afterwards, after we switch it into a fraction form, we use the cross multiplication. And this is useful for solving fraction equals fraction. I intentionally showed you 2 different ways of solving equations in the first example and the second example, so you can choose whichever method you'd like to do. Let's just go through the vocabulary that we learned in this class today. The first word is the proportion. As we said, a proportion is an equation of ratios, of 2 ratios that are equal to each other. Also, the cross multiplication is a technique that we use to solve the fraction equals fraction. We multiply the 2 opposite sides, and they're equal to each other. And then we don't have fractions, we just have an equation, quite possibly a one-step equation, that we can simply divide by something and we get the answer. Thank you for watching this video, and I'll see you in the next one.